The Pythagorean theorem. The Pythagorean theorem states that a squared plus b squared is equal to c squared. The mathematical definition of the Pythagorean theorem is the sum of the squares of the two legs of a right triangle is equal to the square of the hypotenuse. In this formula, A, B, and C are the sides of a right triangle. And it's very important that you have a right triangle. This doesn't work in any other kind of triangle other than a right triangle. And here's a reminder, a right triangle has to include a right angle. The legs of the right triangle touch the right angle. The two sides that create the right angle, so here is our right angle, so the two sides that make that right angle are your legs. And they have to be A or B in the formula. Doesn't matter which one is A and which one is a B, but they have to be A and B. The third side of the triangle, which is always the longest side, is the hypotenuse. If you start in the right angle and you draw a line through the middle of the triangle, you'll run into the hypotenuse, and that has to be C. And the purpose of the Pythagorean theorem is if you have the two sides of a right triangle, you can use the Pythagorean theorem to find the length of the third side. In our first example, we want to find the missing side length, and they were nice in this example, and they labeled them A, B, and C. So if we start by writing the Pythagorean theorem, a squared plus b squared is equal to c squared, and we substitute the values we know. A is 6, so we need to do 6 squared. We're looking for b, and we have c. 6 squared is the same thing as 6 times 6, so that's 36. 10 squared is 10 times 10, that would be 100. We will subtract 36 from each side of the equation. We get b squared will be equal to 64. And the opposite of squaring something is taking the square root. So if I take the square root of 64, we are saying what number times itself equals 64? And our answer would be 8. In our second example, we are looking for c this time. Again, the formula is a squared plus b squared is equal to c squared. A is 5, b is 12. We are finding the hypotenuse this time. 5 squared is 5 times 5, or 25. 12 squared is 12 times 12, which is 144. These two numbers are on the same side of the equation, so we add them together. From there, we take the square root because that's the opposite of squaring something, and we get that c is equal to 13. Try doing the third example on your own. Pause the video right now, complete the problem, and when you are done, press play and the answer will be there for you. The answer to the third example is 7. The last thing that you can use the Pythagorean theorem for is to determine if a triangle is actually a right triangle. This is called the converse of the Pythagorean theorem. We are still using a squared plus b squared is equal to c squared. And what you're going to determine is if the sides that you are given are Pythagorean triples. You want to determine, in this first example, does 3 squared plus 4 squared, does that equal 5 squared? Well, 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, which is 5 squared, so that is a yes. Now the next one, we are going to take 9 squared. 9 squared is 81. 10 squared is 100. Is that equal to 144? No, it's not. For the next one, we want to determine is 10 squared, or 100, plus 24 squared, 576, equal to 26 squared, which is 676. And the answer is yes. Try the next three on your own. Remember, the largest number is always the hypotenuse. The other two, it doesn't matter the order of A or B. Press pause and then restart it to check your answers. Here are your answers for your remaining 3 examples.